Hello. You're still in it, by the way. Your shoulder. Okay. Today we will be implementing a ring buffer, and that's it. It's for creating and consuming requests from a client, and that's it. I've never done it before, but we will. Looks pretty easy. Yeah, I think we just need to implement a few. Oh yeah, it also has to be locking. We have to assume that two different processes are going to be reading and writing. I assume that you kind of need that for a ring buffer, but we will see. Bang. All right, ring buffer. All right, I brought this up. So this diagram. So yeah. So let's see, C++ atomic. So we gotta have that, and then the idea is that inside of a connection, we will have some kind of ring buffer type. Okay. I think yeah. Let's we can implement it in network because we're gonna only implement it in network. It's only going to be used in network. To be honest, it'll probably be used on the client also, server on the client, but let's see. Okay, so from what I understand, it's going to be something like this. Whoa. So we have an array of our types. So it's going to be like struct, let's say packet, incoming, and it's going to be buffer length, something like this, and then it's going to be a, I guess we can use a size t. It's going to be like read, write, right? Is that it? I think that's all we need. Let's say incoming ring buffer. Is that it? Is that really it? I mean, these have to be atomic, right? Let me bring up chat real quick. Forgot to do that last time. Let me bring up chat real quick. All right. Take your dastardly time, bro. Come on. All right. So it's gonna be something like this. So what do we need to implement? We need to implement. Actually, let's just quickly move it to a scratch buffer. So we need to implement a write, a consume. Consume, because like what it does is it reads this thing and then increments it, right? Because the read chases the write where the write is at. Who's that? Check your chat, my man. Hello. Hello. Hi. Okay, so we need a write consume and we need a reset to clear this. So is that it? Is that it? I think that's it. So if we were to assume, if we check our messages real quick, 8 bytes is this, U16, biggest one here. Let's just assume the biggest it's gonna get is like half a kilobyte. That's a lot, but like let's say it's half a kilobyte. 28, 512. So let me grab the calculator. Let's just round it real quick. 512. Let's say 256 buffer. Yikes. Okay. 131 kilobytes per connection, and we're assuming 256 connections. That is what is that? This many kilobytes. This 33 megabytes. That's not that bad actually. That's if assuming full connections is using 33 megabytes of memory. All right, fine, good enough. Hi guys, I'll moderate you are. Give me more. Oh, how do I fucking do that, bro? I don't know. Is it like add as mod? Whoops. What the fuck? I'm getting trolled by YouTube. Alright, done. Okay. 33 megs for everyone is kind of sick, actually. It's not that bad. Yeah. It's okay. Okay, let's make it. Network. So we've got added connections. So let's okay. All right. So I'm locking in right now. Because we're only using it here, we can actually hit them with one of these. And then let's say, let's call it packet incoming. Incoming packets. Yeah. And then we need to implement these guys here. Come on. Okay. Let's hit him with a quick define. Ring. Let's say max hit buffer. And let's set it to 256. And yeah, packet is an enet. It's a message. We have that. Sorry, it is a message. C++, we don't need that. And we need to include this. Bang. So, okay, let's quickly double check. Let me give you also Mr. Original. All right, I trust you guys to not run it down mid. Okay. Shit, why have I never done this, implemented this before? Okay. Alright, issue. So we need a allocation for network. So we need to add that to init. Network init. So we need a. So let's do network memory pool, which is going to be a alloc. That's an alloc. What did I fucking name this type? Whoa. Take your time. There we go. Alloc pool. Did I really call it pool? I did. Okay. Alloc pool. Okay. And then you can import you. Wait, are you here? We're only using it here, so let's do that. So we have this guy, and we want to init you. So we have to do. Okay, let's probably do the calculation. So it's max connections. Max connections times. Let's for now. Oh no, yeah, we could just straight up do the math. Everything's there to do the math for it. So it's max connections times size of message times the length of the buffer, right? Where do you max when you do the define in here, it doesn't take the namespace, right? I hope to God it doesn't. That would be stupid. So this is how much space we need. So we need to do a network memory pool. Network memory pool dot init. Hit it with one of these. Takes capacity. All right, chill. Oh, we should delete this one. I added this when I was a fucking homunculus. Okay. Oh, I should probably. I only have one screen, so I'm scared to open this one. Okay. Error. Do we have an error type? No. Do I have a... I guess we should init this at the very beginning. And then we can... Well, it's kind of fine to let this memory leak because we want the program to crash, but just in case. So this is how it works, right? Yeah, cool. Do we have any other fail states? Yes, we do. Go-tos might be good here, TBH. Oh yeah, I want to quickly change this. std endl L. Fuck are you? Okay. E. Yeah. I see people using Endel a lot. It actually does something different. It's not what you were thinking. It does a bunch of other terminal shit and slows it down. I mean, it doesn't really matter, but like, it's bugging me. All right. Init. Sorry. Network memory pool init failed. Let's hit it with a fuck off. All right. Is that it? Is that what you need? Let's see if I can find it quick. Yeah. I'm in Python land, bro. Yeah. Yeah. My build is so slow. Oops. Yeah, dude. I wanna. You know how Linus Torvalds fucking. He says he painted his room a light green because that's what mental asylums say is the most calming color. That's what I want. What window manager? Is Hyperland. Alright, cool. Let me just double check this real quick. Max connections times the size of the message and the max packet buffer. Max message buffer, right? Max, let's say connection, sorry, max, connection message buffer. Yeah. Holy shit. That didn't change it everywhere, right? Okay, no, it didn't. Okay, good. That's a bit scary. Okay, right, consume and reset. Yes. Okay. Oh yeah, this is one other thing in network. I want to, sorry, not network, messages, HTTP. This union should be named like that. Let's see if there's any errors if I do that. I don't think so. Cool. I hate unnamed unions. Unnamed unions scare me. Okay. So we have the struct, and we want to implement this. Okay, so let's do. Wait, this is never going to fail. Actually, no, it could fail if it reaches the max, right? And then consume is never going to fail. We want to return a void pointer back. I guess a pointer to message. pointer? Do we want a pointer? I don't think so. What would be good would just be to populate a struct. So let's just do void. And it's going to be populate struct. It's going to be an out parameter, I think is best for this. And then this one is not going to fail. Okay, so when we write, I'm going to take a, which one's faster? It's going to be bigger than a pointer, so taking a pointer is a little bit faster, I think. Hopefully the compiler will optimize it the correct way. Gonna write, and then consume is going to be a add param. Let's call it destination. And reset is going to be so let's do what would be incoming packet, right? Like buffer packet, buffer incoming packet, consume buffer, write incoming packet, and then consume incoming packet. And it's going to be writing this all backwards. Incoming packet buffer. Or write buffer write incoming packet buffer consume incoming packet buffer reset. Bang. Bang. So, and it's for each connection. So we need to take a connection ID. Wait a minute. I guess this will change. Lord. I don't know. We can just take this thing, right? The pointer to the connection. Bang, bang, bang. Wow. With the EU. Alright, bro. Okay. Okay. So there is a way to make this easier. Allocate some object-oriented bullshit. Alas. Yeah, egad. What is this? Public, private? Why is there two privates? Is this one for variables and this one for functions? I guess so. Let's do that, I guess. Uh-huh. Uh-huh. How is this done? Public, private, bang. Alright, let's see. So it would be like private goes here, right? It would be like this. Whoops. Something like that. And then public would be my functions. If I'm correct. Like this. Right? Oh shit. Yo, time. There we go. Jesus, how is this anywhere near readable? Private functions? Well, I don't have any of those, right? Probably struct. Don't need that anymore. Wait, sorry, I have AIDS. I have AIDS. Ignore me, bro. It's like that, right? So I have my this thing here. Whoa. Oi, oi, oi. And then it's like this, right? So I have, oh lord. This is why I don't like this fucking bullshit. So these are the dudes, and then everything here. I really don't like public-private variables. I feel like you should just be able to read it like a human. I'm gonna try just not to do that. I mean, let's see. 1 second. Cool. Where are you ever is private within this context? Bro, shut your bitch ass up, bro. So we have to label it like this. Something like that. C++ build times up. Fucking abysmal. Alright, cool. No longer complaining. Maybe we make this one private, I guess. Lord, I hate this. I hate this way of coding. Everything's public. Bug it. Bug it. So then now these are all private functions, right? Oh wait, no, that's not in the class. I'm stupid. It's not in the class. Okay. So we have a connection, and it has these stuff here, right? Incoming buffer, and this thing. So we have a connect. So we have these connections. Oh, yo. See, I don't like it because this muddies how we're doing stuff. So we have this guy here, network connections. and there's a bunch of connections. See, now there's all on the stack. Is that too big? How big can you make global? I know they are fine getting pretty big, but like 13 megs, maybe not. Oh, sorry. No, I'm stupid. So we have this guy here. Can we put this on the stack? I don't think so. It's getting a bit too big. But it would be so much faster. Would it? Nah, let's put it on the stack. Fuck it. Fuck it. No need for Alok. Alok, where? Let's see. No need for you. I would save a bit. That's good, because they're anyway going to last for the entire program. They would never go away, so it's fine like that. Yeah, okay. Okay, let's implement this. So we need to implement Yoo-hoo. Let's put you init previous and all flash. Let's put you I guess at the top. So I gotta hit him with is it like that? Do I have to do that? Cool. Okay, so how am I able to access these variables? I can just do peer. That's so crazy. That's such an insane way. What's a ring buffer? It's like shit, let me draw it out. Oh, fuck it. We're booting up the Excalibur. Alright, it's like this. You gotta, so you have a, let's for now draw it as a circle, right? So it's not actually a circle, it's a 2D array, but it looks like this, right? So this is our memory, right? Where is it? Is it K? Yeah. So you start with a straw pointer. This is our read pointer, and this is our write pointer, right? So one of your processes will keep reading up until it hits where the write pointer is, and when your other process will be writing to the buffer. So what this does is like your network module will keep writing as fast as it can to this buffer up until it hits an error where the read is. This thing will so keep writing, and then the other process will keep reading until it hits this thing. So the idea is that everything is all Gucci as long as this write buffer, as long as this read buffer is faster than the write buffer. Sorry, the write pointer. Sorry, read pointer is faster than the write pointer, because otherwise, when the write pointer goes around and it hits this, you're going to start losing information. Yeah, that's what a ring buffer is. So in this case, we have our network just adding messages into a ring buffer, and then our game state will be trying to consume these messages and editing the game state as fast as it can. It's going to basically be trying to empty this buffer constantly. If that made sense. Did that make sense? I think that made sense. Tell me about this. Called it something else, but data streams. Yeah, you handle. Yeah, it's all about the all that, bro. It's really nothing. All baby shit. Okay, so how are we doing it? How are we doing it? Yeah, okay. I think this is small enough, but it's quite big. I guess we'll test it. To do benchmark when this is stack catalog versus bump allocator. Yeah. Cool. Let's do the reset one first, because I think that's easiest. So all it's gonna be doing. Fuck, wait, how does this right? Shit, what does it? The reset does nothing. Does it just memset everything to 0 and just puts the read where the write is? I think so. So how does this work? So I can just do take your time. There we go. Right, so how can can I just do incoming packets dot read pointer? Is that how it works? Maybe that's a bit bad naming convention. Read position. Write position. Yeah, let's do that. So technically, I can just do like incoming packets dot read position equals 0, and then write position equals 0. Oh, holy! Did I do this right? No, I didn't. Oh shit. Return 1. Oh yeah. Whoops. Move you. That's so slow, man. Okay. I'm pretty sure that's correct. Hopefully I got it right. What's bump allocator? It's like so Usually, when you're making a thing that needs to be fast, you don't want to keep calling syscalls. So, like a malloc is something in the thousands of CPU cycles. So what you do is you make one big allocation and you just manage it yourself. So, for example, in a game, you want like there's some stuff that only lasts exactly 1 frame or like 2 frames sometimes, when you want to calculate speed or whatever, I don't know. So you have an allocation that resets every frame. So every frame you allocate, you do whatever you need to do, and then you free it at the end of the frame. That is like a million billion times faster than calling malloc and free constantly. So yeah. You can know what you can like. Wait, nothing used. Many companies sell them or not. Yeah, I could. Okay. Oh yeah, I need to figure out how to do this thing. What was it? C++ atomic. C++ atomic example. Ooh. Can you just call malloc with a very large input so it gives you a giant memory relay to being used? Memory to being instead of constantly calling. Yeah, that's what a bump allocator is. You do a big. Actually, I'll just show you. This is our bump allocator. You allocate a big old pool at the beginning, and then every frame. Sorry. Whenever you want to allocate stuff, you call allocate, and it will do a little bit of pointer magic, return back a pointer to that memory, and then you just call reset, and all it does is sets the offset back to 0, and it's as if you've freed all your memory. Super duper fast, much faster than calling this for everything. Yeah, that makes sense. Yeah, that's all. Really do need an Armada. TBH. I saw that there was something, a load function. Stores. Yeah, okay. This grinds my gears, bro. Look at the naming convention. Loads, reads. Stores, writes. Why not just make it read-write? Whatever. Okay. Reads and then writes. Read, modify, right? We don't need that. So we just need this one, right? Yeah. Just give me a quick example. So we need... Is there a size T? Size T. That's what we want, right? Atomic size T. So, okay. Let's see if we get this right. Whoops. So can I just do that? Read. Can I just do that? I don't. Oops. What is the include for this? Atomic node.h. Jesus Christ! What is that build? Jesus. But I saw that it was a type def, so I assumed I can just do atomic size T. Is that how it works? I was just testing, that's why. That. Bang, bang, bang. Okay. This load and store instead of real. Okay, let's see. So, did I do that wrong? Did I have to do std this thing? Oh, where'd you go? Bro, I'm just gonna use the long name, bro. Complainers be complaining. Alright, so that means I can do stuff like read position dot, what was it, load, stuff like that. Can I do that? There's another thing we can use. It was a thing that like a increment counter thing I can do. I used it in another project. I don't know what it was called. It might have it. Let's see. Fetch add. Yeah. Real. Okay, cool. What are you studying? I actually finished uni, so nothing. So fetch add, fetch sub. Wait, so no. We don't need fetch add. We just need a add operator. Adds the subjects from atomic value. That's what we need, right? We need this guy. So plus equals. All right. So let's go to the right one. I think that's the little bit easier one. Network CPP. So I can just do incoming hits dot right position. Well, how do I have to load it and then check whether or not it's full, and then I can. Wait a minute. For this buffer, don't I just need the only thing I need is one mutex. I just need a mutex to access the incoming buffer, right? Let's see an example implementation. C++ buffer implementation. So, because we have two processes, we want to be able to read and write. So they both can have access to the array at once, but they can't have access to both the read and write point at the same time. See if there's an implementation. Yeah. Oh shit, there is. Zoom out. Hello. Oh, it's in C++. I'm fucking stupid. So you must have a job while you were the con, and I have one soon. In 2 weeks, I will be an employed man. Unfortunately. All right. Until why do we need a size? Is that a thing so we could just check that? This is not atomic either. Depot. Okay, wait. Nah, we're pulling out the Excalibur for this shit. So we have. So let's say our network is here and our game process is here. And we have values for each of these, right? So like, let's say this is 6 and this is 2. What does this need access to not break things? You can read to the buffer whenever, as long as you have the mutex for. Why the fuck am I having mutexes? Because I want these to be able to work simultaneously. But you have to have a mutex somewhere. Oh, sorry. This needs to gain this mutex, right? Wait, you need to gain both. So then why don't I have just one mutex? All right. Goodbye. Goodbye. Gully. Gully. Let's see. I don't think we need a mutex. Come on. Yeah, so I don't need one. I don't need one. That's what I was thinking. That is what I was thinking. One thread is always writing, which is the network thread, and then the reading is only game state. And so as long as we keep it like that, only game state can alter this, only network can alter this. Let's say modify this. I was overcomplicated, as I always do. Hiya, hiya. Billy, I had a chatter. I had a chatter, Billy. Okay. Okay, so we have to do a check if this thing is greater than max connections message buffer. Did I say that right? Greater than or equal to this thing right there. 21. You know, we have a new thing, arrows DLL D1 errors hapa bruh. Is there nothing here? Lol. Okay. Type error code to yeah, using that is kind of annoying actually. Think about it. Okay, so if this thing is not filled, then we can write to it, right? So we can just do incoming packets dot incoming. I guess we should name this buffer. Buffer, and we take our right position is equal to whoops, we reference this guy here. And then we just do incoming. Oh, we do need a length. Ooh, yeah, that's why we need a length. Because it's a ring. We can't just check if it's the max. Real. Jesus Christ. This is getting like a okay. So it's now instead of this, it's greater than this thing, return 1. If not, we set this thing to that, and then we increment our right position. Okay. If yeah, so if incoming packet stop right position is equal to max connection incoming packet stop right position equals 0, bang, and we increment the incoming packet stop length. This also gets incremented. Yeah. Length, do we need a Sorry. No, if we introduce length, then we have a problem of then we have a problem where we need, because the read and write is updating both, so you do need a mutex for that. So we have to do it without length. So let's do it without length. So and shit, how do we check this? Let's see. Where are you? So how is it when a buffer is full? If it was here, so okay, so there's a case where if we increment it, it's going to be where the right is. But then you do need a wait. Why would you not need a mutex? Yeah, you do need a mutex. What am I? I'm on crack, bro. I'm on crack. All right, give me 1 second. Do I have? Yeah. Okay. Yes. Okay. Plus mutex. Is there has to be a way to there has to be a way for both processes to read and write to the same memory somewhat concurrently to a limit. I'm just too monkey brain to understand it right now. Okay, so let's where'd you go? Multi-threaded. Circular lock-free buffer. Should see what the struct looks like. Gang, just saying shit. Okay. What the fuck? Okay. What the fuck am I looking at? Nah, get the fuck out of here. Get off my screen. Jesus Christ. What was that? Alright, give me 1 second. Oh. This is a bigger pain than I thought it would be. Glee. Glee. Ah? What is that? Glee? Glee! She's dressed up, that's why. Oops. Glee. Okay. Where'd it go? All right, there we go. Okay. Okay, so we have this guy here, right? Okay. Oh, sorry, I forgot. I haven't showed the screen in a while. Oops. Bang. All right. Remake format. Yes, please. Yes, please. Yes. Net CPP. Let's appease the gods by clicking on that. Okay, so we have incoming packet stop, read position, load. Is this a... Yeah. And one of these, and then I saw that this is a... This takes a type. Okay. So I saw that this thing here. Hello. Hello. Okay, let's see this. And yeah, this is the mod thing. Yep, cool. We could have a bit of what the hell? What the hell? Okay. Get this guy here. Oglin, CDP. If whoa. Okay. Yeah, that's okay. That's correct. Okay, that's correct. There we go. Okay, so we assign whatever's in the buffer. We write position store next right thing. There is an increment. Oh yeah. So this is the magic. If you plus one of the mod, you get the position. Yeah, we actually. Okay, cool. And then we do the opposite here. So we can actually just set this. How do we do that? Int. Let's just do int. I like just one. It's better. Okay, so this thing here, let's just do. Are there any other errors we would get for this? I don't think so. This thing here. Trying to. Right, relax, and this is acquire. And this one is the consume, so this one is the relaxed. And this is the acquire. Alright. God. Alright. Okay. Memory order relax. Let's see. C++ memory order relax. There are no synchronization or ordering constraints imposed on other read or writes. Only this operation's atomicity is guaranteed. Okay. A load operation with this memory order performs the acquire operation on the effective memory location. No reads or writes in the current thread can be reordered before this load. All writes in other threads, okay, that release the same atomic variable are visible in the current thread. I'm about to go to bed, bro. What the hell? With you. Yes, I did. That's what I meant. There was another. Oh, yeah, I saw it already. What? Uh-huh. Repause. Next repause. Fine. Okay. Word definition matching this thing. You lying. You lie. No decoration in network continue. Gang, what are you on about? This is what I don't like about these error messages in C++. What the fuck am I looking at? Oh, it's right there. Class connection. Sorry, bro. Just lay it out for me, please. Oh, it's network connection incoming. Okay. Cool. That was a good error message. But I thought I meant the namespace. Yeah. Well, I guess that's not how it works. Can I do that? Gang. Incoming packet buffer consume message pointer DST. I'm a be real. I don't know what it's talking about. What is it on about? It's saying the fix, but it doesn't work. The thing is here. Okay, so no direction for int. Boy, oh my god. Lol. Okay. Relax. And stay relaxed. If thou see why. We need a return 0. Bang. Cool. Kill. I think that's it. I think that's it. I think that is the ring up bell. Done. So let me just quickly see if I can do this. Cool, I can. See what's up there. Nothing. Actually, let's just do magic.ho. Well, let's format you first. Really make format. Maybe we do a little bit of a test. I'm gonna go ahead and say no. Oh yeah, let's remove you. This one we can change it. I'm not sure what other people are working on, so that'll be a little bit annoying to change. Okay, let's see. Network, Aluk, messages, HPPP. Yeah. That no longer is true. And this I can discard. Okay, that is it. The ring buffer info for incoming server requests. Oh, connection. Okay. I guess I should just actually add it to the thing. So we have a receive connection. See, okay. So if I remember, it's event.packet data, right? And so now we can do connection dot what's that called? Bang. Incoming packet. What did you take? Pointed to a message. So we do event.packet data. It's already a pointer. Just do that for now. Lol, what do we do? Drop packets? Question mark. I assume you don't. I don't know how real time this thing blah 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 works, but we'll see. So I can just do that, right? Magic shit right there. And then I can do the same thing here, right? Uh-huh. Lol. Lol la li lu le lol. That's a bit weird, but alright. Sorry, we need to cast this guy into a messages message. Pointer. And same thing here. Take your time. Take your time. All right. All right. Let me ask the client team to add this. Yeah. Should we consult the AI? See if they are impressed. Ooh, sorry. And I want HPP. Any errors? Sir. Let's see. Hello, Cleve. You're wearing something else now? Let me see. Let me see. Why are you dressed? Okay. What? Ah. See what Kimmy says. Why is it building though? Lol. That's an internal. See, it's an internal. Corona is an internal. Star ring is somewhere. Good, that's fine. Incoming ring buffer is struck but nested inside a class. Its members are public, but by default, which you want, but it's highly inconsistent. Shut up, bro. Jesus. Incoming packer buffer reset. Whoops. Cool. Don't care. Don't care. Don't care. It's the only thing it fixed was just my typo and random include I didn't include. That is fun. That is straight useless. That. Thanks. Yes. Okay. Okay, so let's see. The client code, debug menu, UI, CPP. Okay. I guess we have to wait for that. Let us push this, I guess. Let me run, I guess. Yeah, okay. I just need to check. Cool. Let's kill the compilation and push this hoe. All right, that's it. That is it. $1,500 already. Damn. Did not actually get much done today. literally just that. Yeah. Yeah, I'm a little bit suspicious on this disconnect message. What happens if there's a timeout? I don't know how that works. Yeah. Yeah, we need to look into that. IMO. Okay, whatever. That is enough today. See y'all later.